see so many this late in the day. Just very short about me. Work as a senior developer at Wally. It's a small intelligent startup. So if you were at the Daniel Stenberg morning talk today, I'm definitely on that top. We're using open source a lot, and we're providing like things on top of a lot of things that are open source, and we are not that open source, sadly. I started out fiddling with computers, 1986, or 64, and I've been kind of learning stuff since then. I have a knack for sustainability in general, sustainable code, sustainability on the earth too, and I love open source. Yes. Sorry, I'll do mine. Up a bit? Is it better? Yeah. It's better? Thanks.
You don't breathe on it anymore.
Thank you very much. I'm not very used to speaking talks, so this is a bit good feedback. So the Mikado method, just a little poll first. Who have heard about Mikado method before this talk or before this conference? So we have 4 hands or something, and how many have used it? No? Okay. Just curious, I have this intuition that it's not very known in the industry, and I think it should be. That's part of why I'm holding this talk. I want to be more well known because it's a really useful and quite simple tool, really. So I'll give you a minute to just read through, because this is the whole Mikado method. Can you see it? Is it big enough? I'm not supposed to have an exam on this or anything. It's just to get you acquainted with the method. I want to point out something around those two points with a green star here. I've added this green star on the side. So it says draw the solutions as new prerequisites and revert your changes. And these two perhaps are the most distinct things compared to any senior developer says when they're approached with this method that I already do this, I already work like this. These two make it a bit different than they usually mean when they say that. Because they don't usually maybe revert changes. Or they definitely don't, in my experience from the teachings I've done, draw things in a graph. Maybe you do. So I'll just show you what it looks like on a very, very simple problem. A typical problem where I wouldn't use the Mikado method, by the way. It's just for pedagogical purposes. If I can mix the slides. So this is a toy problem. And it's the wrong video, of course. I have a backup on that. Let's go. So, it's the wrong problem. Let me find the right. And I will double the speed for the talk's sake, so we don't spend too much time on it. As you can see on this piece of code, there's some repetition of just what to do for each key press here. It's part of a Tetris game, open source Tetris implementation of finished. And I just thought, oh, this is a very nice little bit of a factory. You can probably just see that this could be a map, like from this key you do this element. Like, we could discuss if that's a better design or not. But anyway, it's a way to present this. So first we draw the Mikado goal. We want to simplify this if-else repetition to some kind of map. So we draw that code in our graph. And then we try to implement this as naively as possible, or wishfully. I usually call it wishful thinking. So what would I like the code to look like? I would like it to look something like this instead. And the AI Copilot just winging it, and it wasn't correct code here. So this is what I would like it to look like. Just map from keys to actions. Next up is, are there any errors? We look at the errors, and we come up with immediate solutions. So the error said there is no such thing as the action map. And the immediate solution to that problem, we have to add such a map. So we draw that implementing a fix for that problem as a new prerequisite. And then we rework the changes. So this is the toughest part. We have done some software development, just to throw away the changes. And then we select the next thing to work on. We start over. Let's try. Seems to work. Are we done yet? Not really, we still have that if-else block. Here it is. So we try to implement it again. And AI did the right thing right this time. How do we know if we're finished? We just check what this green state is. The green state is a concept of mine. It's not part of the original Mikado method. It's just explaining to ourselves what does it mean to have not broken anything. And it is manually testing the tethers. And it doesn't work, so we have broken something. And that's quite obvious because we haven't mapped anything yet. So what's the immediate solution of that problem? We have the maps. And we work changes. And it works again. And we move up to that. And AI understands what I'm trying to do here. So it fills in blanks. And let's try if are there any errors. We run it again. We can run. Nice. So we commit that. try it once more. The goal, to be getting back to the goal. And it worked. Commit the last change. Yeah, so we were finished with that small refactoring then. I want to show you, so this was a trivial refactoring example, just to show the method, the mechanics. This is a little less trivial. So this is the side effect of doing Mikado is you get this change graph, or Mikado graph. For this, this was a simulation. I was interested in discrete event simulation last year, this one of the hard things in such a simulation is that you have to handle certain events, and the kind of main handler just grew fatter and fatter. So it looked like this after a while. So this is the barbershop. It was a barbershop simulation. It just grew fatter and fatter, and I tried to refactor it sometimes just manually, and oh no, there was an error. Never mind, it's fine. And it grew and it grew. So it's, I don't know how many, several tens of lines at least. And in the end, it looks like this. Just split it up in small handlers for each event type. Right? But it's a little less trivial refactoring, get it right. So I thought, oh, this is a great opportunity for Mikado. And in the end, I had to extract some variables first, and then I could move the method for method. And the Mikado graph looks a bit like this. Here's another example from the Tetris you saw just. So this is the graph when I add sound effects, because it's black sounds. And then I Googled a bit and looked for some open source project or something. I don't know if it was open source, but so this is even bigger. This was some project that migrated to .NET Core from some older version of .NET. So it can be infinitely big, really. So what happens when you use, what benefits will you get from using the Mikado method? Well, you get small commits, of course. That's one thing you saw. Another one is that you kind of get unstuck. You avoid this, oh wow, this will be a big change. So you're just stuck in this analysis paralysis. Just analyze how big will this change be. We look through a lot of things, and you get unstuck from that. Just try things and learn from the code base, and start doing changes. Another side effect is that since you have this change graph, you can have it shared with the team or even the organization, just see how big this upgrade of whatever library or something. You can just see this, how big effort it is, really. Because it's quite, if you're not an engineer, if you're working in an organization, there can become questions like, how can this take so long? And you can just show that, well, look how much changes it is, how much work it is. So that's another benefit. Like a kind of popular word right now in at least tech agile community is trunk-based development, because you can actually move those small commits immediately to the trunk, because they're safe. If you have done a good job at defining that green state at least. So that's really nice. You get value early instead of having like a branch, like for weeks or something. And also, you don't make assumptions. It's easy that, especially if you work in a code base for a while, you think you know the code base. But actually, the reality is that you don't. So this method, if you do it with discipline, you stop doing those assumptions. It's just relentlessly pragmatic. Also, it's really nice to go home after work, and you know that you can get back to this change graph. You know exactly where to start again. After. You don't have to have that context in your head. So you reduce that cognitive load. So this is just some benefits. There are more. So that sounds nice, right? What's the catch? Well, I found some things some situations where it's. So I've used this method on and off for 2 or 3 methods, and I've taught it to teams and individuals. So I used it quite a lot. But I think under certain circumstances it's really hard to apply. So I've come up with some limitations with it. So for example, this limitation. It's a tricky one. With any size of system, it's not possible without tests, automatic tests. You don't have the energy, really, and maybe you don't even have the knowledge. Maybe it's been built on for tens of years and no one really knows. There is, for this one, there is quite straightforward, even though it requires a lot of effort, but it is possible. You can add tests to such a system. For that kind of effort, I suggest looking into approval tests. It's also called characterization tests or golden standard tests. I think it's quite the tool for that situation. You can cover large parts of the system with kind of tests, automatic tests that will protect you. And it is quite challenging but fun to kind of do that work. You can try to find some seam in the system which can capture a lot of the behavior of what's happening. And then you get kind of a shield. So that's one limitation. It's solvable, but it's really challenging to adapt the system. You can at least. So another limit where you can't really use Mikado method is that you have tests, but those tests take really more than 1 minute or even less. I think 10 seconds somewhere is kind of limit. It doesn't sound much with 1 minute, but because of Mikado, you try things and you revert. You have a really short cycle, right? It's minutes, within minutes. And if you have that short cycle, 1 minute is quite a long time. And you just lose focus. And you could maybe work with that for a couple of hours, but not for days. It's really tedious. It's like a psychological barrier. So how could you try and work on this challenge? You could try to do any tricks of the book, paralyze test runs, just run subsets of the tests, or use some commercial, I don't know, or open source tooling to really optimize the test running, building test running. There are such tools out there, and be creative. This is quite fun challenge to define a green state test, which maybe it's good enough. For example, if it's a TypeScript source code base, it's quite strictly typed. Maybe it's enough to just compile. You don't have to run the test, just compile. So you have to use your full creativity to find some kind of very short way to ensure that you haven't broken things. That's a way to get around that. There isn't a test where they are taking too long. Yep. Another limit. So we have tests and they are fast, but we don't trust them. They're flaky. I've heard that one. So how do you solve that one?
Use the Mikado method on the test first.
Yeah, make them reliable, right?
Yeah.
You don't want unreliable tests anyway, right? Regardless of, yeah. So what's the pattern with these limits?
They're all about tests.
They're all about tests. Mm-hmm. what is it about tests?
It's TDD basically.
Well, you get tests from PVDs. I mean, what if we don't have tests? What happens then if you make changes? Uncertainty. How do you get certain? Yeah, by testing manually then, right? Or finding some expert that knows what it's supposed to do. So how long time does that take?
Oh no.
A lot of time. It's maybe not even possible. Yeah. And in the unreliable case, right, you could run a lot of times and you get quite confident that it's working. You don't trust the tests for one run, but maybe you can run it 100 times, then you just, I don't know, steal a lot of time, right? So I think the general pattern is the cycle time. If the cycle time is too slow, you can't really apply Mikado. You really need a short cycle time to apply Mikado. So yeah. One time. Yep.
So I'm thinking not yet.
Sure it is.
Oh, yeah, okay. So I'm thinking not just about tests, but in your example, like you have a variable that's not used, which your static code analysis might complain about, or you could have a partial implementation, but then your performance tests complains and stuff like that. So you see limitations in these cases as well, or is it just simple scenarios?
Could you try to rephrase that question so I get it more? You have
So it's more like when steps are too small to deliver the quality bar that you expect. For example, your static code analysis or performance tests. How do you deal with that situation?
so the steps are too small to do what?
For the PR to be green.
Yeah, so I kind of skimmed over that part of the Mikado flow or graph or process. There is a question there which is, does your changes make sense? Kind of. So if you're kind of stuck in this PR flow, your workplace, I know your pain, and you could try to reason with your teammates that it's fine if I define a hash map here. Look at this graph. So that's one way to address it. You could also try to just go for some more parts of the tree, so it does make sense. Maybe it's an upgrade of a library, and people generally like upgrades to libraries. And you had to change some config files. Just the change of the config files maybe didn't make sense. So you could go for many parts, a bigger part of the tree, and then you suddenly have a making sense change. So that's the kind of approach that the book suggests. Yeah.
More questions?
I'm sorry if I'm coming with a stupid question. What's truck-based development?
Truck-based development, so it's the idea that you don't work on several different branches, like in Git, many branches, and you integrate, I think the definition is like at least once a day. So you could have short-lived branches. I have worked with like push to master directly instead, which is you don't have branches. You just make sure that the changes are safe. Push to master or main.
Wait, but I was like, a lot of what I'm doing is like moving away, because like when I started as a beginner,
Mm-hmm.
I pushed to master.
Yes,
And
exactly.
you're not supposed to do that.
You are, if you're...
I'm just supposed to
keep doing that,
get
keep doing that. Don't.
and then I'm fine.
Yeah.
Because I like my branches, honestly.
Yeah.
Like I like how everything is like with the issues, and then if I later want to figure out like, I'm sorry, I think I'm going off topic, but
You won't like it as much in 5 years or 10 years. I think.
So the book was released in 2014. It's more than 10 years ago. How do you think it
holds up still. I think it holds up still, very much. I do think there are, like the green state, I found that it makes it a lot easier to use the method that you're very clear. You explicitly write down what is a safe state. How do I test the safe state? And if that involves manual testing, it usually is to that state, green state. But I think that part, I actually have corresponded with Olof, with one of the authors. I tried to reach the other author, he doesn't answer. So it's very anonymous. But Ola and me, I'll sit down, we get a coffee, and I just brought up all of the things that I've learned about the method, applying it 2-3 years. And he said that this is almost like the second edition of the book. So I think it holds up, but there are some things that can be even more easier to apply it, like the green state idea.
Okay, if I got this right, yeah, you talked about, okay, yeah, having like this small period of time doing something, if it doesn't work, drop the changes, but how long is in your experience, this time window?
Yeah, as short as possible. So hopefully, so for me, you were really trying to do experiments to this system, the source code plus the tests, or whatever you have around it, and you want to get feedback from that system as soon as possible, so you can look at the feedback and make those changes. So I not more than 5 minutes. I don't know. I can't say any hard number, but you're a human, so you have patience and a limit of patience. You want it short.
Okay.
Yeah.
Okay.
Yeah.
So yeah, 1 hour. Okay. 5 minutes, yeah, very short.
Yeah.
Okay, so what if you're not doing trunk-based development? Let's take the Linux kernel, for example. I mean, it's all optimized for reviews, essentially.
Yeah.
So how would this kind of align?
You can still use Mikado in a branch. I work not in trunk-based at work right now. We're working in like this peer flow with branches stuff. So I still work with Mikado on a branch. So it's very much applicable still. You can still use it while developing. You are missing out on a lot of the good stuff. For example, you still have to merge from the main line. Something you don't have to do if you do trunk-based, because you just make so small. Get it in directly.
So my question is not so much about the benefits of trunk-based development versus something else, but rather, so if we take the kernel as an example, I mean, typically your patch sets should be organized in terms of beginning with documentation, API changes, and then implementation. But it feels like the Mikado method goes directly into implementation.
Yeah, yes. Well, you look for the changes that you actually need to do in the source code. Yes. So perhaps, I don't know. Do you actually work like that way, or
Even when I do kernel development, yes.
Yeah. How do you know what changes to make?
Yeah, that's a good point. So usually I start doing the changes, whatever it is, and that could be an arbitrary number of commits, but then usually I have to kind of rewrite it to make it review friendly.
Yeah, yeah.
Okay. Round question. So thank you for coming here.